Hi guys, in this video let's learn about the motion in a plane. Motion in a plane, right? So here, for example, we have a particle here and which is moving in a straight line, right? So now here, to study the motion of this particle, just you required a single, from the Cartesian coordinate system, if you required only one axis, like it may be x-axis, y-axis, or maybe z-axis. If you require only one axis to study the motion of a particle, then it is called motion in 1D or one-dimensional motion. For example, the same particle moving in this direction, right? The same particle is moving in this direction. For this also, you require just an axis in this direction, right? It is an axis, reference line. We call it as a frame of reference or reference line. This reference line is enough to study the motion of this particle, right? So such kind of motion is called one-dimensional motion, right? So now motion in a plane or two-dimensional motion. For example, if the same particle, let's say particle A, and it is moving somewhere like this, not in a straight line. This is the initial position and this is final position of the particle, right? So like this the particle is moving, then definitely you required two axes, right, to study the motion of this object. So such kind of motion is called motion in two-dimensional or motion in a plane. If we required, for example, let me have x-axis like this, okay, and let me take it as x-axis, and coming to y-axis, this is the y-axis, right? Now here, to study the motion of this particle, right, this particle is not moving in a straight line, right? So for example, motion in 1D, best examples are vertically projected body or the car moving in a straight road. These are the examples of motion in 1D. Coming to the motion in 2D, like curve path, etc., right? And projectile motion, the best example of motion in a plane. Now here, this is the initial position of the particle. Let's say I have color also for this. Let me have green color, right? So here, this is, sorry, yeah, okay. So now if I draw position vector of particle A, right? So this is the position vector of the particle. It means from the origin, the particle is, right? This is initial position vector. This position vector is telling the position of particle A1, right? For example, if this particle is at x1 comma y1, what is the meaning of x1 comma y1? If you observe from this on x-axis, okay, from this on x-axis, and also the value of the same particle on y-axis. So here, if you measure from origin to here, it is distance of y1, and here to here the distance of x1, right? The particle A is initially at the point of x1 y1 in a coordinate system, right? So here Ri is called position vector. I can write
in the
like
previous video we have learned about
Ri bar is equal
range,
to
two-dimensional motion.
x1
So now in this video
cap
we are going to prove that
y1
the path of
j cap,
trajectory
right?
is
This
parabola.
is the initial position
That means
vector
let's
of the
have
particle.
an x-axis. Let's have an x-axis and y-axis. Okay. Now here what we are doing is just we are projecting a particle with a u initial velocity, such that it is making an angle theta with horizontal, right? So now here if you observe, I have projected an object. This is a path of an object. This is initial velocity u, okay, this is initial velocity u, and here this u is making, the initial velocity of the projectile is making angle theta with the horizontal. Now what I can do, this I can tell that this initial velocity vector can split into two components. one is u cos theta and another one is u sin theta, right? It can split into two components. Okay, it can split into two components. Now here my target is to give a equation for this path. For example, whenever you draw a straight line in the graph and you can tell that y is equals to x, right? This is the equation of this graph. And if you get a curve path like this, then you can tell that y is equals to x square. Of course, it is like y is equal to mx plus c, and it is like y is equal to ax square plus bx plus c. And at the same time, if you draw a graph for the, if you get like this, then y is equals to, you can take it as root x, 1 by root x, right? Like this, for every shape there is an equation for the graph, right? Like that, when you are projecting an object, it is following reverse parabola. So now what we have to do is, mathematically we have to prove that the path of the trajectory is reverse parabola. Okay, now for that, first of all, what I'll do is, along with x-axis, I'll find out the time, because the distance traveled along with x-axis is equals to the speed along with x-axis into time taken, right? From this, time is nothing but x by ux, and you know very well the ux is nothing but u cos theta. So x by u cos theta, this is the equation for time. Now let's apply the let's apply s is equals to ut plus half at square. S is equals to ut plus half at square, right? This is for along with the y-axis, right? Here the displacement along with y-axis is y, that is equals to initial velocity along with uyt plus half ay t square. And you know very well, along with x-axis there is no acceleration along with x-axis 0. That is why we are directly using distance is equals to displacement is equals to speed into time formula, right? If there is an acceleration, you cannot use this, you have to use v is equals to u plus at, like that, right? But here along with y-axis there is an acceleration, that is nothing but acceleration due to gravity in negative direction, right? The g value always downwards, right? Now here the displacement along with y-axis sy, y is equal to uyt plus half ayt square. So y is equals to uy in the sense u sin theta, and t in the sense x by u cos theta plus half minus g, ay is nothing but minus g, t square in the sense x square by u square cos square theta, right? This is about the t square. Now I can write this equation as like this. Y is equals to, here u get cancels. Now what is there? Tan theta into x minus g by 2u square cos square theta x square, right? Here I represent this tan theta with a, I represent this entire number constant with b. Now I can write this equation as y is equals to ax minus bx square. This is the equation of trajectory. I mean, by using this equation, right? I have changed the shape, like to remember simply, right? By using this equation, you can find position of the particle at any on its path, right? So now here it turned into, if I take tan theta is equals to a, and g by 2u square cos square theta as b, then the equation will turn into y is equal to ax minus bx square. Here minus bx square we are getting, means it is representing the reverse parabola. If you get y is equals to ax plus bx square, it is like this parabola equation, but we are getting here minus bx square, so it represents the reverse parabola. right? On this equation there are n number of times they have asked questions in NEET and JEE Mains and Advanced as well, right? So now here, for example, let me give you one simple question. For example, they have asked a question like y is equals to 8x minus 4x square, then what is the range? Then the range, they asked range formula. So here if you compare these two equations, a is nothing but 8 and b is nothing but 4, right? So now actually the range formula is equals to a by b, that is equals to 8 by 4 means 2 meters. This is the range of the projectile. Okay, clear? So now I'll tell you how this formula came, a by b, right? Not only range, from this they'll give this equation like y is equal to 8x minus 4x square, and they'll ask you find out initial velocity and with how much angle they projected the object, that also they'll ask you, and time of flight they'll ask you, and the maximum height they ask you.
So
let us derive all
if
the
they ask you
equations
to
for
find
this,
out,
right?
for example, if they ask you to find out initial velocity, right? If they ask you to find out initial velocity, then you know very well what from this equation. If you observe here, g by 2u square cos square theta is equals to b, right? From this, if you want to find out initial velocity, then you can take this u square this side and send this b to this side. Then u square is equals to g by 2b first of all, we know that tan theta is equals to nothing but, we know that tan theta is equals to nothing but a na. So here from this equation a is 8. Now if they ask you the angle of projection, then theta is
Hi guys, in this video let's learn about the motion in a plane. Motion in a plane, right? So here, for example, we have a particle here and which is moving in straight line, right? So now here, to study the motion of this particle, just required a single, from the Cartesian coordinate system, if you required only one axis, like it may be x-axis, y-axis, or maybe z-axis. If you require only one axis to study the motion of a particle, then it is called motion in 1D or one-dimensional motion. For example, the same particle moving in this direction, right? The same particle is moving in this direction. For this also, you require just an axis in this direction, right? It is an axis, reference line. We call it as a frame of reference or reference line. This reference line is enough to study the motion of this particle, right? So such kind of motion is called one-dimensional motion, right? So now motion in a plane or two-dimensional motion. For example, if the same particle, let's say particle A, and it is moving somewhere like this, not in a straight line. This is the initial position and this is final position of the particle, right? So like this the particle is moving, then definitely you required two axes, right, to study the motion of this object. So such kind of motion is called motion in two-dimensional or motion in a plane. If we required, for example, let me have x-axis like this, okay, and let me take it as x-axis, and coming to y-axis, this is the y-axis, right? Now here,
to study the motion of this particle, right? What this particle is not moving in a straight line, right? So for example, motion in 1D, best examples are vertically projected body or the car moving in a straight road. These are the examples of motion in 1D. Coming to the motion in 2D, like curve path, etc., right? And projectile motion, the best example of motion in a plane. Now here, this is the initial position of the particle. Let's say I have color also for this. Let me have green color, right? So here, this is, sorry, yeah, okay. So now if I draw position vector of particle A, right? So this is the position vector of the particle. It means from the origin, the particle is, right? This is initial position vector. This position vector is telling the position of particle A1, right? For example, if this particle is at x1 comma y1, what is the meaning of x1 comma y1? If you observe from this on x-axis, okay, from this on x-axis, and also the value of the same particle on y-axis. So here, if you measure from origin to here, it is distance of y1, and here to here the distance of x1, right? The particle A is initially at the point of x1 y1 in a coordinate system, right? So here Ri is called position vector. Ri is called position vector. I can write like Ri bar is equals to x1 I cap plus y1 j cap, right? This is the initial position vector of the particle. At the same time, if I wanna draw final position vector, this is here to here, right? This is the final position vector, okay? This is the final position vector from where to where, from origin to point A2, and it's situated at point, sorry, it's situated at the point x2 comma y2, x2 comma y2. So now here what you have to do is, you know very well, x2 in the sense nothing but position of the particle, right, at the distance on x-axis, right? Position of the particle on x-axis. At the same time, y2 in the sense nothing but position of the particle on y-axis. Clear? So I can tell that this is x2 and this is y2, and also I can write a final position vector as x2 I cap minus y2 j cap, right? So here from the definition we know very well the displacement is the shortest path from initial position to final position, right? So now here if you draw the shortest path, then this could be the shortest path, right? Let me have with a green color, sorry, green it won't appear, right? Let me have yellow color, yeah. So here if I draw a line here to here, right, now from initial position to final position, then this yellow one will show the position vector, I mean displacement, right? This is final position vector. Now this is nothing but a displacement vector r. Clear? So here I can tell that the displacement vector r bar is equals to final position vector minus initial position vector, final position vector minus initial position vector. This is about the displacement. If you want to find out displacement, right, you can find out by substituting this equation, or else simply you can apply vectors law, triangle law of vector. Here the vector which is tail to tail hat, I mean in a right angle, I mean in any triangle, not on right angle triangle, in any triangle, if two sides of the triangle representing with the vectors, right, then the third side which is closing tail to tail and head to head gives you the resultant of those two. Here if you observe carefully, RF, right, this RF is closing the triangle tail to tail and head to head. So I can write from the, by using the triangle of vectors, I can write RF bar is equals to RI bar plus R bar, right? The sum of these two is RF bar from the triangle of vectors, right? So from this also you can get R bar is equals to RF bar minus RI bar. So right, this is the formula for displacement. Hope it is clear. Now let us substitute those values. What is R? Let us substitute those values. R bar is equals to RF in the sense what, Nana? X2 I cap minus, sorry, here it is plus, okay, X2 I cap plus Y2 J cap and minus X1 I cap plus Y1 J cap, right? This is the position, initial position vector, and this is the final position vector. So from these, X2 I cap plus Y2 J cap minus X1 I cap minus Y1 J cap. So now here let's take I common, X2 minus X1 I cap minus, or let plus plus X2 minus X1 I cap and plus Y2 minus Y1 J cap, right? So here this is nothing but a displacement vector. This is nothing but a displacement vector. This is final vector, this is initial vector. So displacement vector is equals to RF minus RI, right? So now here you can write it as a, what is the meaning of X2 minus X1? X2 minus X1 is nothing but R bar is equals to delta X I cap plus delta Y J cap. What's the meaning of delta X? Change in X component. What is meaning of delta Y? Change in Y component. So finally the displacement of any particle in two-dimensional plane, two-dimensional axis is nothing but with respect to X, change in its position with respect to X axis plus change in its position with respect to Y axis. This is about the displacement, right? So now here from, let us see from the graph. If you observe from the graph, here what is from here to here, if you observe, this is nothing but delta X, right? And this is nothing but, sorry, this is nothing but delta Y, okay? This is nothing but delta Y, right? So this is about the displacement of the particles. Clear? Hope you understand how to calculate the displacement of a particle which is moving in two-dimensional, right? Two-dimensionally. So now let's calculate velocity of the particle, right? So if you want to calculate velocity of the particle, then first just whatever you have displacement vector, differentiate both sides with respect to time. Means dr bar by dt is equals to dx, delta x in the sense change in x, dx by dt I cap plus dy by dt j cap, right? We have differentiated above equation both sides with respect to time. Then you will get, we know very well the rate of change of position with respect to time is called velocity. So velocity vector is equals to change in x with respect to time, change in x component with respect to time is nothing but x component of velocity I cap plus y component of velocity j cap, right? This is nothing but velocity vector of the particle, right? So here the direction of velocity along the direction of displacement itself. Clear? It's very clear, right? So now if you want to find out magnitude of this velocity vector, then modulus v is equals to root of vx square plus vy square, right? By using this formula you can find out the velocity vector. Clear, right? And next from the same, if you want to find out acceleration, then again what you have to do, you have to differentiate both sides with respect to time once again. Then you will get dv by dt, that is equals to dvx by dt I cap plus dvy by dt j cap, right? So this is the acceleration vector. We know very well the rate of change of velocity with respect to time is called acceleration. So acceleration is equals to the component of acceleration along with x-axis I cap plus the component of acceleration along with y-axis j cap, right? This is how we need to find, if you want to find out velocity, right? So here for everything you can use a triangle law vector also, right? Triangle of vector, and then you can able to find the resultant, right? So now here, if coming to the next content, if acceleration is constant in your motion in one dimension, you have learned already. If acceleration is constant, like a is equals to constant, then you can able to use few equations. What are they? V is equals to u plus at, s is equals to ut plus half at square, and v square minus u square is equals to 2as, right? So these are not only these, Sn is equals to u plus a into n minus half, right? So these are the equations which you can use, excuse me, yeah, these are the equations which you can use whenever the acceleration is constant. Of course acceleration is nothing but a is equals to dv by dt. If acceleration is not constant, directly by using this equation only you could able to find out the parameters of the motion of an object. Clear? If acceleration is constant, then these equations are valid. Clear? If it is not, then you have to use a is equal to dv by dt. At the same time v is equals to ds by dt. By using these two equations only you have to substitute, right? You can able to change them even to the integration also, right? We will learn them in the while solving the problems, right? So now here in the same way, in two-dimensional motion, for example, just imagine a particle is moving in a plane. A particle is moving in a plane, and this is x-axis, and this is y-axis, x-axis and y-axis. So here initially the particle is here. Just imagine, initially the particle is here, and then it is going somewhere like B. This is the initial position of the particle, and this is the final position of the particle. Here, while studying about this particle in two-dimensional, just you do one thing: study in individually in each dimension. For example, study about this particle along with x-axis and along with y-axis individually. So here first of all you find what is the acceleration along with x-axis and acceleration along with y-axis, right? If you know these two, you can find out resultant acceleration at the same time. What you can do is just like for example, you can apply Vx is equals to ux plus ax into t to find out a final velocity along with x-axis, right? What is ux here? Initial velocity along with x-axis, and ax is acceleration along with x-axis, and time. Here time is same. We can't give the axis for the time right now. And next, in the same way, displacement along with x-axis is equals to uxt plus half axt square, right? And one more thing is vx square minus ux square is equals to 2ax sx, right? So, and one more, what is one more equation? Sn is equals to ux plus ax into n minus half. These are the equation which you can able to use along with x-axis if you know ax right now. And next, coming to along with y-axis, right? if you want to find out any parameter along with y-axis, you must know about ay, and then you can use this formula same. Vy is equals to uy plus ay into t, and sy is equals to uyt plus half ay t square, and vx square minus ux square is equals to sorry, not x, right? What? uy, yeah, along with y-axis we are applying vy square minus uy square is equals to 2ay displacement along with y-axis, right? At the same note is one more, Sn is equals to uy plus ay into n minus of. So these are the equations which you have to use along with x-axis and along with y-axis, right? You separately read the motion of the particle in 2 dimensions, and if you wanna final velocity, then it can be written as v is equals to root of vx square plus vy square, or else if you want a velocity vector, you can find out vx, you can substitute in this vx plus vx I cap plus vy j cap, right? Or else if you want an acceleration, then ax acceleration is equals to ax I cap plus ay j cap, right? This is the acceleration vector, right? Whatever the parameter, whatever the physical quantity you want in order to find out, you can find out them individually. It makes your work very easy. Okay, clear? Yeah. So next, coming to the best example for the two-dimensional motion is projectile motion. Okay, na? The best example is a projectile motion. And one more thing you should remember, that sometimes I'll explain about projectile motion. Before that, one more small important thing. Sometimes what they give, no, position vector they'll give, right? For example, like they'll give velocity vector like this. Let me have, yeah, x-axis and x-axis and y-axis. Okay, na? And here this is the velocity vector, right? Let me take some value they'll give here. Sometimes they give slope, sometimes they give angle theta of velocity. So here, if it is a velocity vector, then its x component is vx is equals to v cos theta, and its y component is vy is equals to v sin theta, if they give theta, right? If they give point like a x1 comma y1, then you can write vx is velocity is equals to xi cap plus yj cap, like that also you can write, if you know, if they give with respect to point. Otherwise, if they give this angle, right, then this is the velocity vector is nothing but v cos theta I cap plus v sin theta j cap. This is how you have to mention if they give theta, right? And we know already, we have learned, if you know this theta, then the slope of this graph can give, this is nothing but a velocity time graph, right? If you take velocity time graph, then slope of it gives you acceleration. So like that you can able to find out. Clear? Next, so coming to next content, I told you already what is that, the best in the sense, the best example for the two-dimensional motion is projectile motion, right? When you throw an object with u velocity by making an angle theta with horizontal, then it called a projectile motion, right? And you can also call it its trajectory. The motion of projectile is trajectory. Now for this, what you will do is, we'll have an object. For example, first let's consider x-axis and then y-axis, x-axis and y-axis. Now what you are doing is, just you are
what you are doing is just you are you are throwing an object by making an angle theta with the horizontal with initial velocity u. Okay, so now what you are doing, this is the path of the projectile. The path of the projectile is called trajectory. What is trajectory means? Trajectory. The path of the projectile is called trajectory, right? So here what we have done is we have projected an object with u velocity, right? With the u velocity. So just imagine here what we have done is we projected an object with u velocity. This is the initial velocity u. Now, and you are making by angle theta, right? By angle theta with horizontal, you projected an object, then it traveled this path, you know very well, right? So here if you observe carefully, if you want to study about this particle motion, then first of all you should know that along with x-axis there is no acceleration to the projectile, right? At the same time, along with y-axis there is a deceleration, means it is also, of course, it is acceleration due to gravity. When this acceleration due to gravity is vertically downwards, right? You know very well, acceleration due to gravity is always downwards and it is towards the center, right? And it is towards the center. So that is why along with y-axis there is an acceleration, but along with x-axis there is no acceleration. So that is why if you observe carefully, this u can split into two components. Right? One is x component and another one is y component. Okay, so here this x component is nothing but ux is equals to u cos theta. See, if it is adjacent side is always cos theta and opposite side is nothing but uy is equals to u sin theta, right? This is about the vertical component of the projectile and it is horizontal component of the projectile. So now here you can write initial vector. I mean, if you want to write initial velocity as in the vector shape, then you can write like this: u bar is equals to u cos theta I cap plus u sin theta j cap, right? This is the initial velocity vector of the projectile. So now here, since there as there is no acceleration along with x-axis, the u cos theta is constant, right? So because what is the acceleration? Acceleration is nothing but the rate of change of velocity. So along with x-axis there is no acceleration when you have projected an object. Because of this, then if the acceleration is 0, then what happens? Velocity is constant, right? Then v is equals to constant. So means a very simple logic that if there is no acceleration, the velocity of change also will be not there. So that is why, that is the reason why here along the x-axis the velocity of the particle is constant. But coming to velocity of the particle along with y-axis, initially velocity of the particle along with y-axis is equals to uy is equals to u sin theta, right? But coming later along with x-axis ux is equals to u cos theta. Just imagine the particle is reached at this point, right? After t time, what happened? The particle is reached at this point. Here what is velocity of the particle? The velocity of the particle is always perpendicular to the, I mean tangent to the, this is the velocity, right? And this u can split into two components, right? One is x component and another one is y component. Here if you observe carefully, this is nothing but vx, initial velocity along with x-axis is ux, after t time final velocity along with x-axis vx, and along with y is vy. Okay, along with y is vy
and then the resultant of these two is v. This is what the resultant of these two. Now here, even though after t time the vx is equals to nothing but equal to ux, okay, and that is equals to u cos theta, because along with horizontal there is no acceleration, right? So there is no acceleration. Because of that, the velocity cannot able to change. It cannot change, right? If you want a velocity change, there should be acceleration along with x-axis. But do remember, sometimes they'll give you air resistance along with x-axis, right? So here, do remember that air resistance can give the deceleration or acceleration. At that time you can use the formulas, but present in the projectile motion along with x-axis there is no acceleration. That is why velocities are same, right? Now here I can tell that vx is equals to nothing but u cos theta. It's never change, right? If you neglect the air resistance in the question, if he mention about air resistance, definitely you must take acceleration because of acceleration or deceleration because of the air resistance. You find out that, then you can apply. Next, coming to vy, we found vx, right? Vx is nothing but u cos theta, and coming to vy is equals to nothing but it is not u sin theta. Definitely it is less than u sin theta, right? Now to find out vy, you use uy plus ayt. Now vy is equals to, what is uy? U sin theta minus gt, right? This is nothing but vy, right? Now if you want this velocity after t time, then you can write velocity is equals to nothing but vx I cap plus vy j cap, vx I cap plus vy j cap. So what is that vy? Now velocity vector is equals to vx is nothing but u cos theta I cap plus u sin theta minus gt, right? Minus gt j cap. This is the velocity vector after t time. Hope it's very clear, right? What is this? It's the velocity vector after t time. So now here, coming to the next case, let's find out maximum height reached by the projectile, right? For example, you have thrown like this. Now here, if you draw a straight line from here to here, right? A straight line from here to here, it is nothing but it represents the maximum height reached by the projectile in its path is called maximum height, right? You can call it as a h max, right? It is the maximum point, peak point of the projectile. And one more important point is, at the maximum height of the projectile, vy is equals to 0. At this point vy is equals to 0, but at the maximum height the horizontal component is same as it is of initial one, right? It is nothing but u cos theta only. Did you understand? Whatever the velocity here also same velocity will be, and here also same velocity will be, here also same velocity will be, u cos theta and u cos theta. But vertical velocity changes. As you're going down, the vertical velocity increases, okay na? The vertical velocity increases. As it is going up, the vertical velocity decreases, okay? The velocity along with x-axis, initially it will be greater, and as the object is going to the peak position, peak point of its path, the velocity along with y-axis decreases slowly and it becomes 0 at a maximum height. After crossing the maximum height, the velocity changes, the vertical velocity changes its direction and it increases, right? greater as it is going to the as it is going to the ground, right? Now here one more important point that you have to remember is, while projecting, with how much velocity you are projecting while striking the ground, you should remember this, right? While striking the ground also same velocity will be. It is very important, right? If you throw with u velocity while striking the ground, also its velocity is u only. Let me have red pen here, okay? Its velocity is u only, and this u can split into two components. One is here the horizontal velocity when it's striking the ground is nothing but u cos theta only, it's never changes. But coming to the vertical velocity is nothing but u sin theta, it is also u sin theta only. Okay, now whatever the value you will get, it will be equal to u sin theta. Do remember u sin theta. With how much vertical velocity the object raised, with the same vertical velocity the object hits the ground, and also with how much angle you have projected, with the same angle with the horizontal the object strikes the ground. Do remember that. Clear, right? And if they ask you, I mean, we'll find out velocity at any point. Now up to now what we have found, velocity vector, we have discussed about the velocity vector, right? Now here they'll ask you like we have found velocity vector. Now they'll ask you angle, direction of, for example, if it is making angle alpha, then this alpha gives the direction of velocity vector with respect to x-axis. That is why you have to find out alpha. So tan alpha is equals to nothing but opposite is nothing but vy, okay na? So vy by vx, opposite by adjacent, right? So tan alpha is equals to vy by vx. Then alpha is equals to tan inverse of vy by vx. So this alpha gives the direction of velocity vector, okay na? But do remember, while striking the ground, alpha is equals to theta, right? Hope it is clear, right? And next yeah, now next what we'll do is we'll find out first time of flight, right? Yeah, time of flight, time of ascent, time of descent, and one more thing is, yeah, time of ascent, time of descent, and one more thing is maximum height and range. All these will find out, right? So now here what we'll do is, again we'll have projectile motion. Let's consider an object, okay? And an object is projecting vertically, I mean projecting with u velocity by making an angle theta, right? We are projecting an object an angle by making an angle theta, right? So here this is the initial velocity vector, right? This is the initial velocity vector, and this is u bar. Let me have white, right? This is u bar, and this u bar can split into two components. One is ux and another one is uy, right? This u bar can split into two components, and I can write u bar is equals to ux I cap plus uy j cap, right? Here uy is equals to nothing but u sin theta, because it is making an angle theta, initial velocity vector, right? U sin theta, and ux is equals to u cos theta. So now here if you want to find out time of ascent in the sense nothing but the time taken by the projectile to reach maximum height is called time of ascent, right? What is time of ascent? The maximum time, the time taken by the projectile to reach up to maximum height is called time of ascent. And what I can do is, to find out time of ascent, Vy is equals to, I mean, I said a reference line of y I have taken, right? The time taken to the object or projectile to reach maximum height is called time of ascent. That's why you'll take parameters along with y axis. Vy is equals to uy plus ay into t. T in the sense time of ascent. Okay na? So now here Vy is equals to 0. I told you already. At the maximum height, the vertical component of velocity is 0. What about a horizontal component? It is nothing but u cos theta only. Again I am telling you, along with horizontal, the velocity is u cos theta only. It's never change, right? Okay na? Because along with x-axis the acceleration is 0. Now Vy is equals to 0. That is equals to uy is nothing but u sin theta minus gta. Okay na? U sin theta minus gta. From this, gta is equals to u sin theta, right now. From this, ta is equals to u sin theta by g. This is nothing but time of ascent. This is nothing but time of ascent. Coming to time of descent. So coming to time of descent, while falling down, what is the time of descent? The time taken to the object to strike the ground from the point of maximum height. At maximum height, I mean here Vy will become the initial velocity for second half, right now. So uy is equals to 0, because at this point initial velocity along with y-axis is 0, and this is nothing but initial velocity is 0, and while striking the ground, Vy is equals to, I told you already, while striking the ground, with how much velocity the object rises vertically, with the same velocity it strikes the ground. So Vy is equals to u sin theta, right now, and a is equals to g here, because the object is falling down, right? So that is why you have to take positive value. So now here, if you want to find out time of descent is equals to nothing but the same equation you can use again. What is that equation? The equation is nothing but Vy is equals to uy plus ay into t, right? Now Vy in the sense what? U sin theta is equals to 0 plus gtd, time of descent. Okay, now from this, u sin theta is equals to gtd, and then you can write time of descent. You can write time of descent, td is equals to nothing but u sin theta by g. This is equation 2. From 1 and 2, it has proven that the projectile, I mean the time of ascent will be equal to time of descent. Okay, so excuse me, just a minute. Okay, time of ascent will be equal to time of descent. Hope it is very clear. Yeah, next let's find out time of flight. As we have found time, as we have calculated time of ascent and a time of descent, it is very easy to find out time of flight, right? Time of flight is nothing but the total amount of time, how much the object stay in the air, right? Or else the time taken to the object to reach the ground from the point of projection, right? So for example, from here you have projected, right? From here to here, how much time the object has taken to reach the ground, that time is called nothing but time of flight. So now here time of flight is equals to time of ascent plus time of descent. So what is time of ascent? U sin theta by g. What is time of descent? Time of descent is u sin theta by g in the both the cases. Now I can tell 2u sin theta by g, right? This is nothing but time of descent. Hope it is very clear of finding out time of descent. Okay na? Yeah, sorry. Now we found time of descent, right? Now let's find out a time of maximum height. Let's find out maximum height. For maximum height, what is the maximum height meaning? maximum height is nothing but the vertical height reach the maximum height vertically reached by the projectile in its journey, right? What is the, if you observe this, I can write like this here. If you observe this from here to, yeah, this is the maximum height, right? This is the maximum height horizontally it has reached, so this is called maximum height, because not horizontally, vertically. So now what we can do is, let's find out h max. So here h max is nothing but, if you want to find out h max, then you have to use formula of s is equals to, for h max, right? For h max, what you have to do is sy is equals to uyt plus half ayt square. Now here sy is nothing but h max, okay, distance vertically, and uy is equals to u sine theta, and ay is nothing but minus g. We are projecting the object upwards, right? Minus g, right? Now let us substitute all these values, then you'll get the h max. Or else simply here in this equation you have to substitute u sine theta by g also. It becomes very complicated. Instead of using this equation, you can use v square minus u square is equals to 2as. It will be very simple, right? For example, vy square minus uy square is equals to 2ay h max, because displacement is along with y axis only, right? So from this what you can do is, you can, vy is 0 square at maximum height. Final velocity of the projectile at maximum height is 0, you know very well, right? And at the same time minus u sine theta square, that is equals to 2 minus g h max. Now minus u square sine square theta is equals to minus 2g h max. Now from this minus get cancelled, so h max is equals to u square sine square theta by 2g. This is the formula for maximum height reached by the projectile during its journey along vertically. Clear? This is about the h max. And at the same time one more parameter is there, that is nothing but range. One more parameter is there, that is nothing but range. So what is that parameter? The range. For example, if you observe the projectile during its journey, the horizontal distance traveled by the object from here to, okay, let me take, okay, from here to here, right now? Did you understand? During entire journey, the horizontal distance reached by the projectile is called range. It is very important. Many questions will become on this. Now what you do is, let's calculate the range. So for range, to calculate the range, yeah, let's calculate the range. Here range is nothing but horizontal distance, right? So horizontal distance is equals to horizontal speed into time, total time, right? So now here r is equals to, what is ux? U cos theta, right, into what is time of flight for entire journey. For entire journey we are calculating range, right? For entire journey the time of flight is nothing but 2u sine theta by g, right? So from these what you can get, this like 2 into, sorry, first you write u square 2 sine theta cos theta, u square 2 sine theta cos theta by g. Then you will get u square sine 2 theta by g. So this is the formula for range. U square sine 2 theta by g is nothing but range of the projectile. You can simply take it a target of the projectile. Okay na? You can call it as a target of the projectile or range of the projectile. Here, if you observe
in the previous video,
carefully,
we have learnt about up to
the range is maximum when you substitute in the place of sine 2 theta 1, right? The maximum value of sine function is 1 only, right? So now what you have to do, you should make it equal to sine function, the equation sine 2 theta is the function, right? So from this sine 2 theta is equals to sine 90. 1 is sine 90 only, so 2 theta is equals to 90 degrees, and then theta is equals to 45 degrees. 45 degrees. Here if you observe carefully, the range is max. The range is maximum when theta is 45 degrees. Very, very important. U square by g. This is the formula of R max, right? So because sine 2 theta, the theta plus if you substitute 45, 245 is 90, sine 90 is 1. So now the range is maximum whenever, okay, now the range is maximum whenever it is when you project object with 45 degree. If you observe recent Neeraj Chopra javelin throw, right? While when he created world history, what he did is he projected an object by 45 degrees. That is excellent. If you, it is available in the YouTube, you can watch that video, right? The range is maximum for u square, I mean when the theta is 45 degrees. At the same time, one more important matter is like for example if you take theta, okay, that's enough for this video. In the next video we'll discuss about the path of trajectory, at the same time problems based on this. Okay, hope enjoying all. Thank you all.
Yeah, in the previous video we have learnt about up to range, I mean two-dimensional motion. So now in this video we are going to prove that the path of trajectory is parabola, right? That means let's have an x-axis let's have an x-axis and y-axis. Okay, now here what we are doing is just we are projecting a particle with a u initial velocity, such that it is making an angle theta with horizontal, right? So now here if you observe, I have projected an object. This is a path of an object. This is initial velocity u. Okay, this is initial velocity u, and here this u is making, the initial velocity of the projectile is making angle theta with the horizontal. Now what I can do, this I can tell that this initial velocity vector can split into two components. One is u cos theta and another one is u sin theta, right? It can split into two components. Okay, it can split into two components. Now here my target is to give a equation for this path. For example, whenever you draw a straight line in the graph and you can tell that y is equals to x, right? This is the equation of this graph, and if you get a curve path like this, then you can tell that y is equals to x square. Of course it is like y is equal to mx plus c, and it is like y is equal to ax square plus bx plus c. And at the same time, if you draw a graph for the, if you get like this, then y is equals to, you can take it as root x, 1 by root x, right? Like this, for every shape there is an equation for the graph, right? like that. When you are projecting an object, it is following reverse parabola. So now what we have to do is mathematically we have to prove that the path of the trajectory is reverse parabola. Okay, now for that, first of all what I'll do is, along with x-axis I'll find out the time, because the distance traveled along with x-axis is equals to the speed along with x-axis into time taken, right? From this, time is nothing but x by ux, and you know very well the ux is nothing but u cos theta. So x by u cos theta, this is the equation for time. Now let's apply s is equals to ut plus half at square. S is equals to ut plus half at square, right? This is for along with the y-axis, right? Here the displacement along with y-axis is y, that is equals to initial velocity along with uyt plus half ay t square, and you know very well along with x-axis there is no acceleration along with x-axis 0, that is why we are directly using distance is equals to displacement is equals to speed into time formula, right? If there is an acceleration, you cannot use this, you have to use v is equals to u plus at, like that, right? But here along with y-axis there is an acceleration, that is nothing but acceleration due to gravity in negative direction, right? The g value always downwards, right? Now here the displacement along with y-axis sy, y is equal to uyt plus half ayt square. So y is equals to uy in the sense u sin theta, and t in the sense x by u cos theta plus half minus g, ay is nothing but minus g, t square in the sense x square by u square cos square theta, right? This is about the t square. Now I can write this equation as like this. Y is equals to, here u get cancels. Now what is there? Tan theta into x minus g by 2u square cos square theta x square, right? Here I represent this tan theta with a, I represent this entire number constant with b. Now I can write this equation as y is equals to ax minus bx square. This is the equation of trajectory. I mean, by using this equation, right? I have changed the shape, like to remember simply, right? By using this equation you can find position of the particle at any on its path, right? So now here it turned into, if I take tan theta is equals to a, and g by 2u square cos square theta as b, then the equation will turn into y is equal to ax minus bx square. Here minus bx square we are getting, means it is representing the reverse parabola. If you get y is equals to ax plus bx square, it is like this parabola equation, but we are getting here minus bx square, so it represents the reverse parabola, right? On this equation there are n number of times they have asked questions in NEET and JEE Mains and Advanced as well, right? So now here, for example, let me give you one simple question. For example, they have asked a question like y is equals to 8x minus 4x square, then what is the range? Then the range, they have asked range formula. So here if you compare these two equations, a is nothing but 8 and b is nothing but 4, right? So now actually the range formula is equals to a by b, that is equals to 8 by 4 means 2 meters. This is the range of the projectile. Okay, Clear? So now I'll tell you how this formula came, a by b, right? Not only range from this, they'll give this equation like y is equal to 8x minus 4x square, and they'll ask you find out initial velocity and with how much angle they projected the object, that also they'll ask you, and time of flight they'll ask you, and the maximum height they ask you. Let us derive all the equations for this, right? First of all, we know that tan theta is equals to nothing but, we know that tan theta is equals to nothing but a na. So here from this equation a is 8. Now if they ask you the angle of projection, then theta is equals to tan inverse of 8. This is the angle of projection. Okay na? And next, if they ask you like initial velocity, what is b? So if they ask you to find out, for example, if they ask you to find out initial velocity, right? If they ask you to find out initial velocity, then you know very well what from this equation, if you observe here, g by 2u square cos square theta is equals to b, right? From this, if you want to find out initial velocity, then you can take this u square this side and send this b to this side. Then u square is equals to g by 2b cos square theta, right? So this is the equation for u square. If you send this square this side, then it will be like u is equals to root under g by 2b cos square theta, right? So now here, if you don't know theta value, for example, from this equation you cannot find theta value, right? Now what you can do is to find out the theta value, you know, right? Here tan theta is equals to 8 na. So 8 by 1 means you take a right angle triangle, right? The tan theta is opposite by adjacent. Then what it will be, according to the law of Pythagoras theorem, you can write this as a 8 square plus 1 square. Then you will get the value of this. Then you will get cos theta value. Cos theta value is nothing but root 8 8 is 64 plus 1 65, root 65, right? And 1 by root 65. From this triangle, cos theta is equals to 1 by root 65, right? This is the cos theta value. Substitute in this place, then you will get the u value. Or else you can do one more thing. What you can do is, let's change this equation. Let's change this equation like what is u here? U is equals to nothing but root of g by 2b into 1 by cos square theta secant square theta, right? Here you know very well secant square theta minus tan square theta is equals to 1. So from that you can write u is equals to root of g by 2b into 1 plus tan square theta, right now. So you can write g into 1 plus tan theta in the sense a, right? So 1 plus a square by 2b, right? This is what this is how you can use directly this formula to find out u value also, right now. Next, coming to, if they ask you find out the range, so here just before I have solved a question here, range is equals to a by b, right? So now what you can do is, let's check a by b, right? To find out the range, you take a is equals to tan theta and b is equals to, what is their b value? Yeah, g by 2u square cos square theta. So now here if you do a by b, what happens? Tan theta means you can write tan theta as sin theta by cos theta, right? You will write that sin theta by cos theta, tan theta by 2u square cos square theta, right? Square cos theta cancel. Still what is there? If you take sorry, not u square by cos square theta. What is b value?
g by 2u square cos square theta, right? Here square cos theta get cancelled. Clear? Now from this you can write, if you take these two numerator, then 2u square cos theta sin theta by g, right? And then that is equals to, you can 2 sin theta cos theta, u square into 2 sin theta cos theta by g. Now you can write it as a u square sin 2 theta by g, so right, which is nothing but r. So from this I can tell that the range of the projectile is r is equals to a by b from the equation. This is also number of times they have asked in the many examinations. Okay, please keep it, do it, remember. And next, and then can we find maximum height? Yes, of course we can find the maximum height. What is the, how can we find? In the sense 4h is equals to r tan theta, 4h is equals to r tan theta, right? So here 4h is equals to r, in the sense just now we have derived a by b, tan theta in the sense a, right? So from this h is equals to a square by 4b, right? This is the equation to find out the maximum height from the equation. If they give equation like y is equal to ax minus bx square, okay, from that equation you can find out height like this. And you can also find out time of flight. Time of flight t is equals to 2u sin theta by g, right? So similarly, same like you can derive that equation. If you derive, you will get like t is equals to root of 2a square by bg. Okay, this is the equation you will get. It's the same way how I derived here range and how I derived here u value here, right? So likewise here, if you observe carefully, I have derived u value now. So likewise, if you try, then you will get the time of flight is equals to root of 2a square by bg. Okay, na? Clear? And next, yeah, this is about the trajectory equation, and likewise they'll ask you questions on this topic. Now here let's check, let's take to the another concept. The concept is about complementary angles. It is very important. On this also number of times they have asked questions, right? Complementary angles in the sense like for example, I have a projectile. Let me take it up. Okay, so I have a projectile, x-axis and y-axis, and now we have projectile, we have thrown this like this. Right, this is the projectile. Clear? And you have projected with the, no need always, you know, right? If you project with u velocity u theta with by making angle theta with the horizontal, then it can split into two components, horizontal component and vertical component, right? So now here, just imagine this is angle, sorry, yeah, this is with angle oh, it is angle theta 1, right? With this is the angle with the theta 1, and again what you did is you have another projectile with the same velocity, and you projected once again, this time with angle theta 2. Okay, so this is the projectile one. First time you have projected with u velocity, then it reached to this point, right? At the same second time also you projected. This time what you have done, you have taken angle theta 2. This time the angle is theta 2, right? Here if you observe carefully, in the both the conditions, the range is same. In the both the conditions the range is same. So I can tell that theta 1 and theta 2, right? For these two, what happened? The range is same. Now if you take the range equation, the range equation is r is equals to u square sine 2 theta by g, right? U square sine 2 theta by g. From this, r is equals to u square, and for example, let's substitute in the theta value 30 degrees. For example, if you substitute 30 degrees, then what happens? Sine 2 into 30 by g. Now here, from this you can have u square sine 60. Sine 60 is nothing but root 3 by 2g, right? In the same way, let's have with the 60 degrees, range with 60 degrees, right? U square sine 2 into 60 in the sense 120 by g. Here u square sine 120 in the sense 90 plus 30 by g. Now r is equals to nothing but u square cos square theta means, sorry, u square sine changes into cos for 90. So that is why u square cos 30 by g. Again cos 30 is nothing but root 3 by 2g. Root 3 by 2 is the cos 30. So in the both the conditions, if you observe, when the theta is 30, the range is same. When the theta is 60, the range is same. Here 30 and 60 are called complementary angles, means theta 1 plus, I will write here, sorry, means complementary angles in the sense theta 1 plus theta 2. Theta 1 plus theta 2 is equals to 90 degrees. This is called nothing but complementary angles, right? Now here the range is same. The range is same for the both the angles, for theta 1, for theta 2. Clear na? So this is the main concept that we have to consider, because here if you wanna find out theta 2 can be written as 90 minus theta 1, right? Clear? As well as if you wanna take theta 1 is 90 minus theta 2, right? These angles are complementary angles. For the complementary angles, you should remember that the range is always same. Next, here in this condition, if you observe, first you consider, first what you do is, this is h max, h1, and this is, right? So here this is h maximum height in the when the angle of projection is theta 1. The velocities are same for both, and this is h2, right? What is maximum height by the when the angle is theta 2, right? But the range is same. Now there are few relations between the h1 and h2, right? So first thing is, let me take, of course height is h1 and theta 1 is the time of flight when the theta is theta 1, I mean angle is theta 1, and t2 is the time of flight when angle is t2, right? Now I can write here, right? Yeah, I can write here t1 is equals to 2u sine theta 1 by g. At the same time t2 is equals to 2u sine theta 2 by g. Here u is same because we are projecting in the both the cases with the same initial velocity. Okay, do remember that. Now if you perform t1 by t2, then 2u sine theta 1 by g by 2u sine, in the place of theta 2 you can write 90 minus theta 1, right? If you observe here, what is there? theta 1 plus theta 2 na. So theta 2 is 90 minus theta 1 by g. Then theta 1 by theta 2 is equals to nothing but 2u get cancelled, g get cancelled, and then sine theta 1 by sine. For 90, sine becomes cos, right? So you can write directly cos theta 1. So I can write sine theta 1 by cos theta as a tan theta 1. So t1 by t2 is equals to tan theta 1, right? Directly you can find out this. Clear? Yeah. And next, one more relation. If you multiple t1 and t2, right? If you multiple t1, this is one equation, one relation between t1 and t2, which is very important, right? And next, if you multiply t1 and t2, that is, what is t1? 2u sine, 2u sine theta 1 by g into 2u sine theta 2 by g, right now. So from this, what you can do is, you know very well that, you know very well that 2u square sine theta 1, if I change theta 2 as a 90 minus theta 1, theta 2 as 90 minus theta 1, then I will get cos theta 1, right? 2 u into u square, still 2 is there, by g square, or g into g only you write. Now 2 sine theta cos theta 1 can be written as u square into sine 2 theta 1 by g into, still 2 is there, right? 2 by g, right? Now u square sine 2 theta 1 by g is nothing but range, right, into r by g. So from this I can tell that t1 t2 is equals to 2r by g. So this is also a very good relation which they ask you. Once they ask a question based on the relation t1 into t2 directly proportional to range, okay, based on this relation they have asked previous one question, check properly, okay. And next, coming to one more relation. For example, there are two heights are there now. What is h1 there? H1 is equals to, you can write like h1 is equals to u square sine square theta 1 by g, 2g, and h2 is equals to u square sine square theta 2 by 2g, right? Now you can write sine square theta 2 as a cos theta 1, right? Now we have done already before, right? You can write cos square theta 1 by 2g. Now if I do h1 by h2, then I will get u square sine square theta 1 by 2g by u square sine square, u square cos square, right? U square cos square theta 1 by 2g cancel, u square cancel, then you will get tan square theta 1, right? Either theta 1 or theta 2, no problem. So this is one of the equation important. h1 by h2 is equals to tan square theta 1, very very important, okay. On this also they have asked questions. And next, like that if you take, you'll have many equations, right? Now one more, like a very famous POQ it is like h1 plus h2. So h1 plus h2, h1 is equals to u square sine square theta 1 by 2g plus u square cos square theta 1 by 2g. Theta 2 in the place, you can write cos theta 1, right? We know already, because theta 2 is equal to 90 minus theta 1, right now. Yeah, from this, if you take common u square by 2g, then sin square theta 1 plus cos square theta 1, then you will get u square by 2g into 1, right now. Means h1 plus h2 is equals to u square by 2g. This is also very famous and well used equation, right? And these are the about complementary angles maximum. These are the relations which they can ask, and a few more also are there. If you want, let me give you directly equations, just use them to solve the questions, right? So for example, they'll give you ranges, I mean you know that, right? 4h is equals to r tan theta. What is that relation between the maximum height and range, right? Very important one, relation between maximum height and range. From this you can take same thing here, right? 4h is equals to r tan theta. Here tan theta means nothing but you can write theta 1 by theta 2, right? 4h is equal to r theta 1 by theta 2, or else here tan theta is nothing but tan square theta is h1 by h2. So from this r is equals to, I mean you can change according to your wish, however you want, right? In the place of tan theta you can substitute t1 by t2, just here is there now. Yeah, t1 by t2. What is t1 by t2? Yeah, t1 by t2 is tan theta 1, right? You can substitute that. So or else by using this equation you can substitute the in the tan theta place root h1 by h2 also, right? According to situation you can find this, okay now. So from this with this we have completed the projectile motion. In the next video we'll discuss about the relative motion, right? Thank you.